Hi, this is Iqbal Khan. I am a technology evangelist at Alachisoft. Today I will talk about how NCache, the NCache Split Brain Recovery architecture, and also give you a demo of it. NCache is an in-memory distributed cache for .NET and .NET Core applications. It also supports Java and Node.js applications. NCache is used in high transaction applications where your application is running on multiple application servers. These may be your web applications, your microservices applications, or any other server applications. And NCache sits in between the application tier and your database, be that be a SQL Server or Oracle type of relational database, or any NoSQL database like Cosmos DB or MongoDB, or any legacy mainframe database or data. And NCache usually has 2 or more cache servers in a cluster. And for this mission critical application environment, NCache provides you high availability. And as part of that high availability, there's a very important feature called split brain detection and split brain recovery that I'm going to talk about. But before I go into split brain, let me quickly give you an overview of the NCache dynamic cache clustering architecture. This is a TCP based architecture where every server is connected to every other server through a TCP socket. It is a peer-to-peer architecture, which is self-healing. Self-healing means it automatically adjusts itself to any changes. And there's no single point of failure because of that peer-to-peer architecture. That means there's no master, there's no slave. There is a cluster coordinator node, which is usually the oldest node in the cluster. But if that ever goes down, then next oldest node automatically becomes its successor. A cluster coordinator is responsible for managing the cluster. It manages the cluster membership. It manages, in case of a partition or partition replica topology, it manages the data distribution map. And it also manages the health of the cluster. Now, as I said, every node in this cluster is connected to every other node, and it keeps track of that connection. And if that connection ever breaks, there's a connection failover feature within the cluster, which is that node automatically does retries, multiple retries, which is a configurable option, and each retry has a timeout. So, there's also a heartbeat feature where it keeps sending a heartbeat at a configurable interval to make sure that that socket connection is up. The reason all of that is done is because in most situations that is sufficient for ensuring that any connection breakage is automatically restored or recovered from. And the reason for that is because the cache servers are usually deployed in the same data center, in fact, in the same subnet. So the connection between these cache servers is usually very reliable, and the split brain does not happen very frequently, but sometimes it does. When it does, then I'm going to talk about how we manage it. Anyway, this architecture allows you to add or remove any cache servers at runtime without stopping the cache or any of your applications. And whenever you add a cache server to the cluster coordinator updates the cluster membership map and dynamically propagates it to all the cache servers, who then dynamically propagate it to all the clients. And then similarly, if it's a partition or partition replica topology, then even the data distribution map is updated, which is usually, and you can go into the NCache architecture video for more details on that, but partition or partition replica topology has 1,000 buckets, which is the distribution map, and the map basically tells the servers which buckets each server has, and when that is sent to the clients know where the data is. So this is the dynamic cache cluster. The second aspect of this is the dynamic client connections, which is that just like the connection within the cluster is dynamic, the connection between the clients and the cluster is also dynamic. And actually, it's a very light TCP-based connection. If that connection ever goes down, there's again a connection failover feature where there are retries and timeouts. And there's also a keep alive feature where the client keeps sending a heartbeat type of a message to the cluster to make sure that the connection stays up. Actually, the connection breakage probability between the clients and the cluster is more likely than within the cluster itself. And the reason is because the clients could be deployed in a separate subnet, even across the firewall. So all of that usually increase the chances of sockets breaking. So whenever that happens, the clients are able to reconnect. So there's a connection failover feature. And this entire architecture allows you to add or remove clients at runtime without stopping the cache or the application. And whenever a client is added, the client obtains the cluster membership information from the cluster. And then if it's a partition or partition replica topology, then it also obtains the data distribution map that I showed here from the cluster. And that allows the client to automatically know exactly how many servers are in the cluster, who are they, so it can connect to them in case of partition or partition replica topology, and also know what the data distribution map is. So in light of all that architecture, there is still situation, despite the fact that there's resilience built into the TCP connection through retries and timeouts, but a connection may actually genuinely break between the cache servers for some reason. It could be a hardware reason, it could be a network driver issue, or it could be any variety of information reasons. Whenever that happens, we call it a connection breakup. So in the cache clustering architecture, every node in the cluster keeps detecting whether there's a connection breakup, which means that despite retries, the connection still broke. Whenever a connection breaks up, each node assumes that the other node has died. So it keeps talking to all the other nodes. So for example, if you have a server here, this node is talking to all three of these. So this node may go down. So this node may be able to talk to these three. When that happens, it will assume that these three are now a cluster of three and this node has left. So when something like that happens to, let's say, a cluster of 6 nodes, and I'm just going to give the example that the connections break up in such a manner that 3 of them are able to talk to each other, these 2 are able to talk to each other, and this one is not able to talk to anybody. So when that happens, when these nodes are detecting all of that, then they all assume that, okay, I am a cluster of 3 because I'm able to talk to these 3 nodes. And when I'm a cluster of 3, then one of my nodes is going to become a cluster coordinator, which may already be a cluster coordinator, because if it's the S1, which was probably the oldest, and that continues to be the cluster coordinator here. But in case of split 2, S4 becomes the new cluster coordinator for this cluster. And for split 3, S6 being the only node becomes the coordinator as well. Now, in this situation, these nodes know that these 3 nodes they're able to talk to these 3 nodes. So it says, okay, I'm good. The others have died. This thinks the same thing. I'm good. The others have died. This thinks I'm good. The others have died. But they also know that I'm supposed to be a cluster of 6 nodes, and so they keep trying to ping all the other nodes to see whether they're going to come back up. And the pinging happens for a configurable interval, after which they will just give up and assume that these nodes have permanently gone down, and I'm the only one left. But within that interval, if, let's say, the network connection restores, and these nodes are now visible to each other. So let's say all of them are able to see each other in this example. So now they realize, oh, we have created 3 separate splits, but we are able to talk to each other. So now they will NCache will formally detect a split. Even though the split happened the moment the connections broke, NCache nodes did not know that this was a split because they thought they all had died. But if those nodes came back within that specified interval, then NCache nodes will say, okay, a split has occurred, and now it's time to do a split recovery. And the reason this is done is because your application needs a healthy cache cluster in order to continue working. And although the split is not a healthy situation, if you can recover from it automatically, it does not, instead of your admin staff having to intervene at odd hours of the day or night or weekends, then it makes your life easier. NCache automatically comes back to a healthy state, a healthy cluster of 6. But how does that happen? The first is that split is detected. As I said, it is detected only when the connection is restored and they're able to see each other. Until that time, they assume that others are dead. Okay, now that split is detected, now the split recovery kicks in. What is involved in split recovery? So in split recovery, the two largest subclusters or two largest splits are merged first. And the cluster of this split and the cluster of this split, they coordinate amongst themselves to say, okay, since I'm the smaller of the two, and the size here is based on the number of nodes in each cluster. It could have been based on the amount of data. It could have been based on amount of activity, number of clients, but we chose number of nodes because that was the most likely situation, because in most situations, every node has pretty much an same amount of data because of the hash map distribution, because of the fact that there are about 1,000 buckets that are evenly distributed, because of the fact that there's a data balancing feature in NCache that rebalances data across nodes if it ever goes out of the balance. So all of that means that the most likely situation is that every node has approximately the same amount of data. So the largest number of node means the largest amount of data. So that becomes the master. And this other split has to give up its data and rejoin this cluster as fresh nodes. So the first thing it does, it gives up its clients. It tells, so these two servers, this coordinator tells its other node that, okay, we need to give up the clients and tell the clients to connect to this cluster. So the first thing that happens is the clients move to the new cluster, because this is the master cluster. Once the clients have moved here, now this cluster gives up its data, and essentially you can say it reboots. Although it doesn't reboot, it just gives up its data and rejoins this cluster as a healthy node. And now as a result, you have a 5-node cluster, which is a merging of split 1 and split 2. So after that is done, then it goes to the next largest split and merges that with this. Now you may, in our case, we had only 3 splits, but you could have more than 3. And the algorithm is you start with the largest and you merge it with the next largest and the next largest and so on and so. So you go through as many iterations as you need to, but at any point in time, only 2 splits are merged. So while these 2 splits are being merged, the third split is considered independent. It's going to continue to do its operations until the split is merged. And now this merge is going to happen. And if there was a 4th split, that would be merged after this one as well. So in this process, please note that depending on how many nodes had to lose or give up its data, you will have data lost. So for example, in this case, 3 nodes become master, the other 3 lose their data. Even in a partition replica topology, you only have 1 replica per partition, so you will lose data. And that's just a part of this situation. However, the other part of this reality is that if for data caching situation, this data is already coming, this already exists in the database. So you're not losing the data, you just have to reload it from the database. You could reload it based on the hit and miss of operations of your application. You could also reload it based on read through. You could also reload it based on cache refresher feature of NCache. But either way, that data is not lost. However, if the data was more of a session state, any other transient data that did not exist in a permanent store, then that data you have lost. So in that case, you have to recreate those sessions. But despite that data loss, is still a better situation, because after all, you have had a failure of network. So that has consequences. In the next version of NCache, we are going to be providing a persistence feature where you can have the cache persisted. So, and a persisted cache means that whatever was in the cache is kept in its own, NCache's own persistence store. And that way, in a split brain recovery, you will not lose even the transient data because NCache is keeping a copy of it on a persistent store. But I'll go over that when that feature is made public. So at this time, I'm just going to talk about this. So I hope I have explained this architecture. Now I'm going to actually give you a demo of exactly how you can do this in NCache. So I have an example where I have 5 cache servers, and I'm going to create a split between this and this. So I'm just going to create these 2 splits. Split 1 is going to contain these 2 cache servers, and split 2 is going to contain these 2 cache servers. Then I've got one Windows client that I'm going to use, which is where I'm sitting right now, which I'm going to use for doing management and monitoring. And I have a Linux client that I have two shelves open to this client, so I can have two separate client applications launched from there. So I have this cluster running right now. I'm not going to show you how to add this cluster, because there are other videos that show you how to do that. I'm just going to show you the split brain part of it. So here I've got a 5-node cluster. Actually, I've got a 5-node cluster. Where would that go? So I've got a 5-node cluster, which is right here, and it's running. Okay, and I'm going to actually go ahead and open its statistics, and I'm going to also open its monitor. So what I have done actually is I've opened two different NCache manager windows. One is connected to the .97, which is right here, and one is connected to .82 right here. So this one is .97, which I've got the actual manager, I've got the monitor, and I've got the statistics. And the second one is the .82, and I'm going to again do this again. It's the same cluster, but I'm just talking to a different server for management. I'm talking to this server as compared to this one right here. And in this, I'm going to again do statistics, so I can see the activity. Currently, there's no activity because I don't have any clients running yet. And I'm going to also open the monitor. So why did I open two of these? Because I want to monitor, I want to connect to this node and I want to connect to this node, so that when I do the split, I can see, because if I'm only connected to this, when split happens, it's just going to show that I've got only two servers left, and these it's not going to be able to see. So I want to see this from both perspectives, because I'm going to introduce the split through a firewall rule. Of course, in your case, you're not going to have the firewall rule. You will have some sort of a network outage. So I'm going to sort of introduce or simulate that through a firewall rule. So I'm now connected to this node for management and monitoring, and this node for management and monitoring. And I'm going to now come here, and I'm going to, oh, no, not yet. I'm going to also use this command line tool called get caches -server, and I will talk to .82 here. I'm going to talk to .82 and say, give me the detail of all the caches that you have. So .82 is saying I have a cache called demo cache in which I have 5 servers: 82, 102, 122, 97, and 117. You know, a 5-server cluster, which is because there's no split right now. I'm going to go to the other server, the 97. I'm going to ask it the same thing. I say, give me your server. It also says, okay, I've got a 5-server cache: 82, 102, 122, 97, and 117. Currently, so it's 5-server cluster, no split, everything is fine. Everything is working fine. I'm going to now start the application. I've got a PowerShell window. Actually, this is a Linux box right here. I'm going to show you what happened here. Come on. I'm just going to open PowerShell again. My apologies. I'm just going to import this module, which is the NCache management module. You only have to do that on Linux. You don't have to import this on Windows. Then I will say test stress demo cache. Okay. So now I've run this one of this tool. I'm going to do the same here. I'm going to say test stress demo cache. I've got both of these. Now watch. I've got activity happening. I've got activity happening on all 5 nodes, as you can see here: 1, 2, 3, 4, 5. On all 5 nodes, I've got activity happening. Right here, I can see that. I can see that here as well. I've got 5 nodes, and now this I'm talking to .97. Again, this is .97. Now I'll see if I can see the same here as well. So I'll go to .82. And I see I've got 5 nodes, activity happening. the statistics window is also showing activity. Okay, so everything is working fine. Normally, I would not open this NCache manager or monitor on two different servers. The reason I'm opening is because I need to show the split. And when split happens, I need to show you from both sides of the split what is happening. Okay, now that I have everything running, I'm going to now go ahead and introduce. So what I'm going to do is on these two boxes, I'm going to use the firewall rule. So I'm going to use firewall here. I'll use a firewall here. So I've got those two rules already set up. So I'm going to log in. I'm logged into 97 here. I've got a rule here. I'm going to go to the, let's say I've got an inbound rule. It's NCache. I just called it NCache Split Brain. This rule is saying block the connection on what? It ports 78 to 7900. That's the cache. So NCache starts a separate process for every cache. So that cache process uses by default 7800 to 7900 port, although it's configurable. So you may be using a different port, in which case you have to block those if you want to simulate this. And port 8250 is the management port, and scope is saying block for 82, 102, 122. So I'm telling this one, block these three boxes from accessing you. That's basically what it's saying. So I've got this port. I'm gonna say enable rule, and I've got the same port for an outbound rule. So it's blocking for outbound. And now I'm gonna go to the 117 and block that as well. I'll come to 117. Again, I have an inbound right here, same thing here, block connection, ports 78, 79, scope, all these three boxes, okay? So I'm gonna say enable rule, that's enabled. I'm gonna go to the other one, I'll say enable rule right here. Okay, now what I have done, I have turned on the firewall on all of these, so now the split is gonna start happening. Although it's not gonna happen immediately, and I can see that by, I'm gonna first ask 82, which is this, how many servers do you have in the cache? It says, okay, I've got 82, 102, 122, 97, 17. So it still has all five because the split hasn't happened yet. It's still going through the retries and all that other stuff. I'm going to ask the other one, how many servers you have? It still has 1, 2, 3, 4, 5. So no split has happened yet because it's still going through retries and timeouts. But the split is going to happen soon. I'm going to come here and see if it's starting to see some stops. So I'm talking to 97 here. 97 is the 2-node cluster side. So 97 is telling me that it is only seeing 80. So it's not seeing 102, 122, and 82. It's saying those are stopped, but 97 and 117 are running fine. Okay. Let's see what is the other side showing. The other side of the split, which was this other side. So I was talking to 97, now I'm going to talk to 82. As you can see, this is the 82. Right here is the 82 IP address. It's saying, okay, it's saying 102, 122. So it's saying 122 is partially connected, and 82 is fully connected. It's still going through it. That recovery, it's still going through this retries phase where 122 is not able to talk to some of the other nodes, but it's going to go ahead and actually, what's going to happen is, I'm going to actually quickly show you. So there's a feature here that I told you about, that in the cluster, if there's a partially connected node, it removes that partially connected node from the cluster to create a healthy cluster. So that's what's happening right now, is that it is removing that other cluster, or that other node, which is a partially connected node. Now let's come here again and now see what does the command line say. I'm talking to 82, which is, as I said, that's the 3-node cluster. So it should, let's see how many does it have now. Oops. Right here, it's saying 82. It has 1, 2, 3, 4. So it's got 4. It doesn't have 5 yet. It has 4. It's still going through the, it's going to forcibly remove the nodes as they are. And now I'm going to go to 97, which is right here, and I'll say, okay, how many servers do you have? and lo and behold, 97 only has 2. So 97 has already established the fact that it cannot see the other 3. So it thinks, okay, I'm the only cluster here. It doesn't know there's a split because, as I said, the split only, NCache only knows about a split when this connection is restored. So right now it just thinks the other nodes have died. So, and it says, okay, I'm going to continue with myself with these 2 nodes. And let me go to the other one here. Let's see, what does it have? Oh, okay, now it also has 3 left. So it has gone through and it has also done this. It has removed the partially disconnected node to now reach a healthy cluster, but it's a cluster of only 3 nodes, right? So it's got, so I talked to server.82 here, which is right here. I asked it, how many servers do you have in your cache? It says only 3. I asked 97, how many servers do you have in your cache? It says only 2. Okay, so a split has happened. As part of the split, you will see that so far the application has not thrown any exceptions. That means the split has happened without any data loss. This probably could be that the application has not encountered, but in some cases you will encounter some exceptions. Okay, now the next step that I'm going to do is now go ahead and actually kick in the split brain. So I want to now restore the connection so that split brain is detected and a recovery is started. So but before I do that, I'm going to show you that in my cache configuration, if I go to the cluster settings, which is the first topic here, if I go all the way to the bottom, I have already enabled auto recovery for split brain. So if you enable auto recovery, that means NCache will automatically recover from a split brain once it detects the split brain. And as I mentioned, it detects the split brain when the connection is restored. So, okay, let's now go to both 97 and I'm sorry. So let's now go. Hold on. Let's go back to 97 and this and turn off this firewall. I'm gonna do on 97 first. I'm gonna come here and I'll say disable this rule. And I'll come here and I'll say disable this rule. Okay. I've done that. Now I'm gonna come here to 117 and I will say let's do disable the rule here as well. Disable the rule. Disable the rule. Okay, now I have disabled the rule, so this firewall is turned off. That means they are now able to see, or pretty soon they will be able to see each other. It's not going to happen instantaneously, but they will be able to see each other. And as you can see, so I'm going to actually come here again, and I will say, show me your cache. I will keep this in front of me, and I will say, I'm talking to 82 right now, and I say, show me your caches. 82 saying I've got 82, 102, 122. So far it still has 3 caches. It's not seeing the other 2. I'm going to go to the other one, and I'm going to say, show me your caches. It's saying 97 and 117. So far split brain recovery has not kicked in, but it will. It will, because it takes a little bit of time for the retries to happen. As you can see here, I'm seeing 1, 2, 3, 4, 5 servers already, and here 1, 2, 3, 4, 5 servers. But I'm going to again depend on my good old command line PowerShell tool to tell me I'll do that get caches call. I'll talk to 82 and I say show me how many servers you have. It still has 1, 2, 3, and I say show me how many servers you have. Right here it still has 1, 2. So again 1, 2 and 1, 2, 3. So no connection has been, so the split brain has not been recovered from yet, and that's why it's still going partially connected, and the clients are continuing to work. Okay, let me go again. Let's do another one. Oh, it's still not done. Okay, go here, 97. Come on. Okay, now it's starting to see the other node, 82, 102, 122, and also 97 right here. But it's still partial because it needs to see two of these. It needs to see both partition and the replica. And that's why it's probably not able to talk to 97 yet, because okay, now 82, 102, 122, 97. Again, 5 nodes are restored here, all 5. Let me go to this one. This one, somehow it, come on. Actually, what I'll do, I will change it here. So instead of 82, I'll say 97 here. When I do that, I'll see that 97 also is showing me 5 nodes. 1, 2, 3, 4, 5. Okay, so all 5 nodes are reconnected. I'm going to come here. Let me just restart this monitor. I will come here again. This cache, I'll say statistics. I'll see all 5 are working and the clients are talking to them. So again, the fact that the client is talking to all 5 means the client connections are also restored automatically. And the monitor is also going to show me all 5 here. So as you can see, fully connected, all 5 nodes. Okay. Now let me come here to the other one. Did I go to the other one? This one. Okay. I'll say, okay, statistics. All 5 are, I'm talking to all 5 here. As you can see, activities happening on all of them. And I'm going to say monitor. All 5 are happening here. So we went from having a healthy cluster to having a split to again having a healthy cluster, and we're able to see that here as well, that we have a 5-node cluster. So that's pretty much the end of this demo. Please go ahead and play with NCache and see that with Split Brain Recovery you have this added capability of high availability.